In one of the previous sections, we created a new library inside of Android Studio, and we imported that library into our Xamarin Forms project. During this section, we're going to be working with similar things in the case of iOS, starting precisely with that creation of a native library, in this case in Objective-C within Xcode, and exporting it over to a Xamarin Forms project. In fact, it's going to be the exact same project that we saw in that case on Android Studio with a Contacts app class that is also going to have a name, a last name. Let me go ahead and show you those. A name, a last name, an email, and the greet contact and by contact methods. And so I already have pretty much the same implementation. We're going to have the hello name last name and goodbye name last name methods. This is also going to be returned by this method, so exactly the same thing that we had on Android. Of course, again, this Xcode project is available in the resources for this lecture for you to download, but of course you can do this with whatever Xcode library that you may already have. So let's go ahead and first learn how to export this library from Xcode, so eventually we can import that library into a Visual Studio project. So the first thing that I will do is go ahead and open my terminal. And inside of the terminal, I want to build this library for different architectures. So architectures that are going to be able to run on different versions of the iPhone operating system. And in fact, because I'm going to be testing it on a simulator, I will also have to build this for iPhone simulators. So all you really have to do is navigate over to where this project is located. In my case, I will be able to find it inside my documents, inside an Xcode folder, and inside, of course, of Contacts application. And notice that in here I have an Xcode Proj file. All I'm going to do then is going to run the Xcode build command on this particular file, the Xcode Proj file. Make sure that I'm going to be running this 4 times, including one for iPhone Simulator. So I targeted the iPhone Simulator with a clean build in release mode. And so I just run this for the project to be built. I see that the build has succeeded. And what we're going to see now is going to be this build folder right here inside the Contacts app folder where our Xcode project is. What I'm going to do is simply move one file that is going to be inside of this new folder so it's easily accessible. I will, for example, move this over to my desktop. And the file that I want to move is this lib contacts app file that has been created. Notice that I have just entered the build and the release iPhone simulator folders. And so I will simply copy this file. While copying, and by the way, I want to make sure that I want to rename this file so I can easily identify this one as the one for iPhone Simulator, and also because I'm going to be doing this for other 3 versions of the operating system, I don't want this all to be called the same. So I will just copy this to my desktop. And again, I will have to do the same thing, and let me just get out of this folder. So I am back inside of my Contacts app where my Xcode project is. I will have to do the same thing for other 3 builds for ARM7, ARM7S, and ARM64. So this same command, except I am going to change the target to be iPhone OS and target the architecture ARM7 first. Everything else is going to be exactly the same thing. Now, before I run this, make sure that you're targeting iOS 10 or earlier. And the same thing is going to happen for ARM7S. If you're targeting iOS 10 or earlier, you can do these builds. If not, you can skip them and go directly for ARM64-bit, which is every single iOS device since the iPhone 5S, I believe. So again, if you're targeting something earlier than iOS 10, you have to build for those 2 versions as well, ARM v7 and ARM v7S. If not, in my case, for example, I am targeting iOS 12, I can skip them and just build from ARM64. once I have done that, I will now be able to find, inside of the same build folder that we saw when we built this for the iPhone simulator, a new release, but for iPhone OS, not for iPhone simulator. So let me go ahead and get inside of that folder, because in here we're also going to find a libcontacts app file, which is the other build. I am also going to move this over to my desktop, but making sure that I rename this file. So again, I'm going to be setting a different name for each of the builds. And you would have to do the same thing if you were targeting the ARM v7 and ARM 7S architectures. Because I'm only going to have 2, but you may have 4 versions in here. So 4 different files with different names. In my case, for example, this one is going to be named ARM64. And so I just move this, and I'm going to have now, and let me navigate over to my desktop, those 2 files. So I have the one for the iPhone simulator and the one for the iPhone operating system, in this case only for the 64-bit version. Now that I have these 2 in the same folder, what I want to do is combine them into a single file, into a single universal library. For that, I will call the lipo command. I'm just going to be calling this the same thing, but without any suffix. And I just establish the name of the 2 libraries, or the 4 if you have 4 versions. And I'm missing a command in here after create. I will establish this as the output. And so I will now have this single file with both builds included. Perfect. From here, the steps are very similar to the ones that we followed when we had our Java library, that we created an AAR file. That AAR file that we had is going to be the Android version of this A file that we have here. And so what we have to do is, let me go ahead and close Xcode. We're not going to be using it. And what I want to do is, over here in Visual Studio, I want to create a new solution. And this could also be a project, but I will do it so it's more similar to what we did with Android. And notice that on iOS, we also have a library section and a bindings library option, just like on Android, when we created a bindings library from Android. And so on iOS, I will select this bindings library project, and I will call this again Contacts Library iOS. So I just hit on create. And now inside of this project, again, just like we did on Android, we have to add that library that we have just exported from Xcode. So let me go ahead and find my file, which is actually in my desktop. And all I have to do inside of this project is, in the native references folder, I am going to add a native reference. And you guessed it, this is going to be the .a file, the combined.a file that we have just created with the 2 builds, or the 3 or 4 builds that you may have. And as soon as this is added, just like with Android, we're going to be able to convert this into a DLL file that we're eventually going to be importing into the same contacts app that we used in the Android case. So if you remember, we don't yet have the iOS implementation for that contacts project, but we now have this native library inside of a bindings library for iOS. We can now do the same thing that we did for Android. Now, before we do that, for the iOS version, we do need a few more steps. And you can actually have a sneak peek about what is needed inside of the API definition.cs file. Ignore the first part of these instructions because this is actually deprecated. We actually now have to use the native references instead of this first part that is described in here. But notice that what we have to do is bind these Objective-C classes. And you have some examples. To bind this Objective-C class, you have to bind it in C# like this. To bind some properties, you have again some examples. Of course, we're also going to be doing that. That is exactly what the next lecture is about. For now, you already have that native iOS library exported into a .a file for 2 builds, in my case, or more builds if you are supporting earlier versions of iOS, and already imported into a bindings library for iOS. In the next lecture, then, I'm going to complete the binding for my Objective-C class right here inside of this API definition.cs file.